In this video, I just wanted to kind of review finding area between curves, a couple different problems, and then I'll also look at a free response. So first of all, finding the area bounded by the equation x squared, or the function x squared and x plus 6. I'm going to do this one totally by hand without a graph. So the first thing, of course, I really need to do is get the intersection points. So I'm going to set the two equal to each other. I'm going to subtract everything over. I use my algebra here to figure out where they meet. So I'll do some factoring. I got to figure out what adds up to -1 and multiplies to -6. It's going to be x minus 3 and x plus 2. So 3 and -2 are my solutions. Those will be the bounds of my integral. Okay, so we're going to go from -2 to +3. Now you need to figure out which function goes on top. X squared or x plus 6. We could pick an interior point, so a point within the bounds, maybe 0. So 0 squared is 0. 0 plus 6 is 6. So the line is on top. So we always do the top function minus the bottom function, like that. That's our integral. Now, to do this by hand, we need the antiderivative, so 1/2 x squared plus 6x minus 1/3 x cubed, evaluated at 3 and -2. If we plugged in 3, we get 9/2 plus 18 minus 9. If we plugged in -2, we get 2 minus 12 plus 8/3. Maybe do a little simplifying here. We have 18 minus 9 is just 9. 2 minus 12 is -10. So we could get rid of parentheses. We'd have 9/2 plus 9 plus 10 minus 8/3. So we'd have 19 plus 9/2 minus 8/3. And from here, I'm kind of out of room. You could get a common denominator of 6. You could actually combine everything. You could use a calculator. Remember that on the AP exam, if this were like a free response question, you could actually stop. I'm going to put just a star here. You could stop right here with the 9/2 plus 18 minus 9 minus 2 minus 12 plus 8/3. You could stop right there. You do have to actually plug in the bounds, but you don't have to proceed past that. In this problem, find the area bounded by x cubed minus 2x and x plus 1. So you can see my graph here of the cubic and the line, and I did label the intersection points in there. We're going to need two integrals, okay? Because for this right here, the integral from -1.532 to -0.347, the cubic function is on top. So we're going to have x cubed minus 2x minus x plus 1 dx, like that. And for this other area right here, the line is on top. So from -0.347 to 1.879, we'll have x plus 1 minus the cubic, like that. So we'll find each of those and then add them up. Okay, so just have to be careful on if there's a change in what function's on top and which one's on the bottom. Finally, I wanted to look at this. This is a free response question from 2 years ago. One thing that they didn't put, well, let's read it, and then I'll include this point. Let R be the region in the first quadrant bounded by the x-axis and the graphs of natural log of x and y equals 5 minus x as shown in the area above. Find the area of R. Now the one thing they didn't give us here is the intersection point, so I graphed it myself, and you can see that I did include the intersection points on my graph. This was a calculator question, so the expectation was you would want to get the intersection points with your calculator. Now finding the area of R, what you're going to notice here is that we could break this into two parts. Okay, let me do a red piece here. So the red is just defined by the natural log of x. So from 1 to 3.693, using the graph that has the intersection points, we just have the natural log of x dx. But then here in this blue portion, from 3.693 to 5, we're defined by the line 5 minus x dx. And we would just add those two together. That would give us the total area. That was one very valid way of doing this. The other way you could do it is by changing it to be dy. And let me just kind of turn this graph a little bit. You could see, looking at it sideways, that looking at it this way, the line is always on top and the other function is always on the bottom, the curve. So if we were willing to change it to be an x equals and do dy, we could actually do this in one integral. So changing this first one, okay, to get rid of natural log, we do e to both sides. So e to the y equals x, because e to the natural log of x is just x. And this other equation, if you kind of do your algebra, maybe add the x over, so you have x plus y equals 5, then subtract the y, you end up with x equals 5 minus y. So we do the integral. Remember, we said the line was on top, so it would be 5 minus y minus e to the y dy, and now the bounds go from 0 to 1.307, because in the y direction, and we start at 0 and we go to 1.307. That's the top bound. Okay, so I'm going to put in just the word or here. Either one of these worked and would get you full credit. The expectation is you use your calculator and FNInt to get the answer. But if you were going to do dx, you had to use two integrals. And that was really a common mistake the year that this was on the exam.